Welcome to Doti Academy. So this research title control measures of COVID-19 in the populations. So this video research tutorial is designed to predict the future hazards associated with COVID-19 if necessary precautions is not taken, and also to provide solutions and control measures associated with the pandemic of the virus using mathematical modeling of the virus in the populations. So if you notice any discrepancies in this model, please email me at jam.986@gmail.com, because I'm a physicist, not mathematics. I'm just trying to make sense of what is happening in the world now. So here, the parameters involved in my model include the susceptible populations. The susceptible populations imply these are the populations. This is the population that has the likelihood of contacting the virus. You will agree with me that every individual in the world have the likelihood of contacting the virus. The disease has no respect for the social hierarchy, whether you are rich or you are poor or you are educated or you are not educated. All you have to do, you have to take the necessary precautions instructed by the government. So you have the exposed populations. The exposed population. The exposed population at this stage of the disease is asymptomatic stage. This is asymptomatic stage of the disease. That is the population who has the disease, but there is no signs of the disease in his or her body. It's moving around fine and good. So you have the infected population, which is divided into two: the non-educated infected, the educated infected. The non-educated infected is a class of the population who is obviously infected, shown by the symptom in his or her body, but is not educated to take him or herself to an isolation, therefore spreading the virus to the people around. Maybe he may decide to go on taking the local drug to treat the disease, therefore infecting others who are very close to him with the disease. So you have the educated infected, i.e. educated infected is the symptomatic stage of the disease affecting the educated class of the populations. You have the quarantine. This is affecting the this is the infected population who is in isolation taking the treatment as regards the COVID-19. You have the recovery class. These are people that have recuperated of the virus. They already have the virus. They went on quarantine. They went to the government, and the government put them in an hospital or put them in an isolation room and have them treat, and they respond to the treatment by recuperate of the disease. So here you have the variables involved in the model. The variables are the fertility rate. The fertility rate you have as the natural birth rate. The birth rate. So you have the mu representing the mortality rate. The mortality rate, that's the rate at which people die in natural death. You have the chi to represent the rate as which people die of this pandemic virus of COVID-19. The rate as which you have people to die of the COVID-19 represented by chi. You have beta. Beta represent the incidence rate or the force of infections. The incidence rate here means the average number that an infected individual is able to infect throughout his whole life of being infectious. That's the beta. You have the gamma to represent the rate at which educated individual is exposing to the virus. The rate at which the educated individual is contacting the virus. You have the theta to represent the rate at which non-educated is exposing or contacting the virus. You have the gamma to represent the rate at which non-educated individual turning out to get treatment and quarantine from the government. You have the lambda to also represent the rate at which educated individual is turning up for treatment and quarantine, and you have epsilon to represent the rate at which people under treatment are getting recovered. You have xi to represent the rate at which people that have recovered are getting back to the susceptible class, to get back to being infected of the disease. So here is the flow chart of the disease. The flow chart represents the flow of the disease in the populations. Here you have the 6 compartments: susceptible, exposed, quarantine, the infectious, both uneducated and educated, you have the recoverers going back to the susceptible. So this susceptible and this susceptible is one and the same thing. Instead of drawing an arrow back to the susceptible, I decided to put susceptible here very close to the recovery. So because there is a relationship between susceptible and recovery, because I say xi is the rate at which the recovery are getting back to the susceptible. So here you have the flow chart. Pi, the recruitment into the susceptible class, the natural birth rate coming into the susceptible class, mu, the rate at which people die a natural death, as in the susceptible divisions of the populations. You have the force of infections. The people who are forcing out of being susceptible, getting into the infected populations. You have beta function to represent that, going into the exposed class. The rate as people are exposing to the population, you have E. So the rate as people in the exposed population die a natural death, and you have this arrow to be going out of the exposed class. So in this particular flow chart, I'm going to use this flow chart to formulate equations. Anything that is flowing into each compartment is going to be considered as positive. Those that are flowing out are going to be considered as negative. So pi here is flowing into the susceptible populations is positive to the susceptible. Mu is flowing out is negative to the susceptible, and beta S into IU plus IE is flowing out is also negative to the susceptible. Beta IU plus IE is positive to the exposed because it's flowing into the exposed. You have mu E to be flowing out negative, and the theta flowing out is negative, and gamma flowing out is negative. So here you have the equations. You have the rate of changing of susceptible. The rate at which you have the susceptible charge to be changing in the populations is pi. Recruitment in the population flowing into the susceptible population is considered as positive. You have it here, flowing into the susceptible population positive, and phi E is flowing into the susceptible population. Phi R flowing into the susceptible population, you can see that flowing into the susceptible population is also considered as positive. Beta IU plus IE flowing out of the susceptible negative, and mu is also flowing out of the susceptible negative. But when you consider the exposed population, that the exposed population beta SIU plus IE is flowing in positive. So gamma E and theta is flowing as negative, and mu also negative. So here you have it, beta IU plus IES flowing in positive, minus gamma, mu, theta, they are flowing out, they are considered as negative, they are all of E. So the same thing applicable with this. This is how I formulate other 4 models. So here is the characteristic equations of the model. The characteristic equation which is obtained by considering the eigenvalue. Eigenvalue you have as determinant of A minus lambda I is equal to 0. Determinant of A minus lambda I. A is the matrix and lambda is the parameters used in the modelings, and the I is the identity matrix. So my A is going to be obtained by this, is going to obtain from these equations. So you are going to consider the susceptible. You are going to form a matrix by these equations and have it as A minus lambda. The lambda is susceptible, exposed, non-educated, infected, the educated, infected, quarantine, and the recovering, and the I is identity matrix. So if you use that and calculate the determinants, you have the characteristic equations of this kind. So in my next video, I'm going to be showing you how to use these characteristic equations to determine the way through which we can have this disease control in the